In this video, I'm going to rebuild the drive side on my chopper rear wheel. So since the last video I made, I took an old mountain bike hub that I had and the rim that was originally on this bike, and I welded these spokes to make a mag wheel, which I think came out pretty nice. However, this wheel's had some problems. I've already had the hub snap off here, and I went ahead and made a sleeve and welded it all back together. However, taking a look at the other side, the bike is currently usable, but in here is a spot for what they call a ratchet ring. It's the part that actually engages the free hub. So, you know, this way it doesn't engage when you turn the pedals backwards, but when you turn them forwards, it engages. And that ratchet ring sits inside the hub, and then inside that is a bearing that the wheel rides on. And when I take the wheel apart, those areas where the ratchet ring and the bearings sit are oblong. So as a temporary fix, put in a ratchet ring and the bearing, and I seated them in there with JB Weld, so at least they wouldn't wobble around in there. So I have some ideas as to how to get this job handled. It's going to be a large one, and I think kind of interesting, so I decided to go ahead and do a video on it. So I have this chunk of aluminum rod. I believe it's 2 inches in diameter that I plan to use to try to make the housing. And I took the hub apart and got some measurements. But the first challenge is going to be this. This is the ratchet ring. And you can see how it is that it's kind of got this sawtooth pattern here, you know, where the free hub engages here to push the wheel along, but then can easily, you know, slide past in this direction. It uses what they call pawls. They're little, they're just little pieces that are kind of like spring-loaded, and they kind of pop into here. But then when it wants to go the other direction, then it kind of drops down so it can go to the next tooth. And that's the clicky-click sound you hear when you're coasting on a 10-speed bike or you know, derailleur bike, is those little pawls kind of clicking over these teeth. However, this is held into the hub with these these protrusions here, and I have a lathe, but that's it. So that's going to be really tough to machine. So that's the first challenge. I think that what I'm going to do is I'm going to try to cast a piece that'll weld into the final hub here. So I have this old plastic wheel. I think it came off a piece of gym equipment, and I went ahead and lathed, you know, cut a cavity in here, and it's got a recess in there. I'm not so sure how well you can see that, but the idea is this almost snaps in there. Well, it kind of does actually, because what I need to do is, if I want to make a piece out of casting that this ratchet ring will go into, I need to make a positive. So you don't cast negatives, you cast positives. In other words, I need to fill this gap now with something that's going to harden, and then that's what I'll actually cast. And this ratchet ring won't be part of the casting process. So that's the first step. Now I know that, you know, when this piece is complete, the positive is complete, that the ratchet ring will be concentric to the outside. It's a nice part about doing it in the lathe. So I put a little bit of this general purpose lubricant on there to act as a mold release. And I've got some flour here and some sodium silicate, what they call water glass. And I'm going to mix the flour and the sodium silicate to make a paste and stuff it in that mold. I don't know that that's the best option here, but I know that they use sodium silicate. In fact, I got it for, you know, making plugs for casting. So I'm thinking it might work well here too. We'll give it a try, see how it works out. I'm trying to kind of come up with a paste consistency here. So this stuff cures when it's exposed to carbon dioxide. And when I made my last plug, it took quite a while. So this may be sitting here for a couple days. I'm starting to wonder if I'm actually going to get this apart in any kind of semblance of something useful. But well, I guess we'll see. Well, my first shot was a fail. Maybe try this again. So it's been about a week and a half, and I think the sodium silicate is cured. I'm hoping all the way through. It feels pretty solid, pretty hard. So now the task is to get this ratchet ring out without destroying the rest of the part, and then I can cast this piece to make the mating portion for the ratchet ring. Well, I was trying to cut off the excess material on the lathe, and it all broke apart. So I don't think that there's enough of a piece here that's going to be useful. So I'm going to try filling it up with the sodium silicate again. This time without trying to make it into a paste with the flour. I'm just going to use this straight sodium silicate, see if I get better luck. Well, let's see if this works. So I've got a hunk of aluminum in here chucked up that I'm going to use to make the drive side of the hub. I got that from Alro. I think I got like 18 inches or so for about $10. It's surprising. I mean, some people think that these tailstock pieces are worth a lot of money, and if you go to the right place, you can really get a good deal. So anyway, we get that faced up, and then we'll start machining it. So this is a hole that I'm boring through the entire piece for the axle. I measured the other side, and it's 0.95. It doesn't really require the accuracy of a boring bar, but well, the other parts do, so I'm just going to go ahead and bore it. Besides, I don't have a drill that's that big. So I took the measurements from the hub the best that I could. Wanted to make sure I had those. I mean, obviously I can take the hub apart again, but wanted to make sure I had those before I started chopping everything apart. So not the best drawing, but it's good enough for what I need, I think. So I'm hogging out the bore for the bearing to go in there, and I kind of I'm on the inside on the diameter, so it's not quite as wide as it needs to be, and it's not quite as deep as it needs to be. But I just wanted to kind of like hog it out and get close first. The plan here is that I'm not going to go all the way to the diameter of the bearing, because I have a tool that I made to make that bearing, the bearing surface exactly parallel. When I first welded these bars onto the hub to make this wheel, I got a little too hot in here, and it kind of wrecked the race for the bearing. So I made a tool to kind of cut those, I guess, the weld, where the weld came through, to cut those, and it's parallel, so it locates off the bearing on the other side. So when I weld my new drive side in, then I'll go ahead and cut that so that it's going to be as parallel and coaxial as possible to the bearing on the other side, which is going to be important to having this wheel roll properly. Got this bearing surface cut with about 20 thousandths left on the diameter and about 5 thousandths left on the depth. So hopefully that's enough meat. I guess it's a little late to wonder about it now. So I've got my ratchet ring in there. Of course, I'm going to have to, at least by the current plan, I'm going to have to bore that out some more because I'm going to be casting the the mating feature and then welding it in there. But it's nice to know that I got that in there pretty good. So, with a little bit of care, you can take a piece of machinery like this, which isn't very high precision. This is essentially a Harbor Freight lathe, but, and do okay with your machining. You just kind of have to sneak up on your dimensions and take it a little bit at a time, assuming that the mics and so forth on here, they may move a little bit, and there's going to be a lot of flexure, especially with a boring bar. Take a little bit at a time, and it can work out okay. So I'm pretty happy with this. So there's a little bit of binding right now on this. There's a little bit of binding right now on this rubber gasket here, but I'll probably be boring that all out quite a bit more anyway, so it shouldn't be a problem. So the plan was to go ahead and cast a piece out of aluminum that I would stick in here and then and weld it in. But I'm not necessarily certain how well that's going to work. And notice here there's 6 of these, I don't know what you call that, cogs or protrusions. So I was thinking it might be nice to be able to scratch lines there every 60 degrees. I wasn't quite sure how to do it and get it accurate. And I think what I'm going to do is I have a level on the chuck key, and I got it right in there. And I'm going to go ahead and scratch the surface with my boring bar. So let's see how this works. So I've got my boring bar right against the surface there. I'm just going to drag it across. And I've got a nice scratch there. So I've got my marks there. That's probably way closer than I would have been able to get with a protractor, I'm thinking. Anyway, that might come in handy for an alternate plan should I need to come up with one. Well, this thing's been sitting around curing for about 2 weeks. So if it's not fully cured by now, maybe it never will be. So let me see if I can't get that ring out of here and see if we can make a mold. So I'm going to try to support this over the baby food jar. I'm just going to try to tap this thing out from the back side a little bit at a time. Oh, look at that. It's all breaking apart. I think it's back to the drawing board. So I'm trying to make a plug. I just dripped some wax from a candle into here. So just wondering if that's going to work. We'll give it a try. Looks like I might have a workable mold. So my first attempt at trying to get this to release didn't work out so well. So let me try again. Second fail. Another fail. Starting to wonder if this is something I can do. Well, I don't think this is going to work actually. So I'm going to try to cast this as lost wax. So what I'm going to do is just stick this in the sand. Got a little cavity here. I'm going to stick it in the sand, fill the sand in the center, just pour the aluminum right onto the wax. So I don't have any experience with that method, but I think that might be my best option at this point. So I've got this sink piece from an incinerator to act as a fence so that when I pour the aluminum in there, it just doesn't go like spilling all over the floor and everything. Like I said, this is the first time I'm trying this, so just going to try to pour it in there and hope that the wax melts out, and what I'm left with is something that I can use. Well, that didn't work, not even a little bit. So anyway, I think I'm just going to abandon this this attempt altogether, find another way to lock my ring into the hub. So I'm going to need to take this piece out of the lathe and then get it back in there. And I could use a 4-jaw chuck, but I'm way too lazy for that. So what I've done is I've just marked it in such a way that I can get it essentially in the same position in the chuck when I'm done with my next operation. So the new plan now that the casting didn't work is I'm going to need to have some sort of a feature to catch these edges of the ratchet ring. So I'm going to start by cutting a slot on the marks. So in the process of making an unbelievable mess out of my machine part, what I did is I welded some raised spots there on the inside, and that's to catch the lip here. So now what I'm going to have to do is machine that so that it's not too raised. Now I have my ratchet ring in there and the little nubs in there so it won't turn. So I think that I'm still going to try to put a piece of steel in these slots. Two of the slots didn't line up, so I just welded them shut. I'm not sure if I'm going to try to cut them again. I'll think about it. So here's the old drive side that I'm trying to replace. Just broke another ratchet gear, so I think it's time to cut this off and replace it. You recording?
Yeah.
So I had the hip turned down on this, and it fits in here just as it should. And as I measure from the front of this piece to the rotor, I needed 3.86, and that's what I got. So it's time to weld this onto the hub. So I've got a piece of all thread here in the hopes that as I weld this, that it doesn't go kind of sideways on me. So obviously, I need the bearings to be parallel, and there's no way for me to mount this in a lathe and cut those bearing races. Although I do have a tool to cut one, but the closer to parallel I can keep it, the better I'm going to be. So I'm finishing up this hub repair. This is welded on just at the spokes. I think that's going to be plenty strong enough. That weld is a total mess, but the rest of them aren't too bad. So anyway, for this hub, at one point the brake side broke off, and I made this tool. And what it is this fits snugly into the bearing, and then this has got a cutting surface here. And then the idea is that, and the cutting surface is just an angled cut there, but that works pretty well actually, especially on a soft metal like aluminum. But then the idea is that that the bearing will guide this other bearing to be on the same axis, right? So as long as that bearing doesn't move as I'm doing this, and I drive this with a drill, then this will cut the new race in here. And I made that race a little bit small so I can cut some material out of it, and so it's not oblong, so it should be round and concentric. So that's the plan here. After several attempts using that tool, I was able to cut this bearing race. So since it was just on a drill and I wanted to get down fairly exact, I cut a little bit to measure, cut a little bit of measure, but that bearing's in there where I want it now. So I think it's time to get a coat of paint on this and see if I can get it on the bike and see how it works. I've got my wheel assembled, and the bearings seem to roll really nice. The freewheel works really nicely now too, which it wasn't before I got started with this. So hopefully I got a reasonable fix here.